So for this video, we're going to be going over section 3.1 limits. So to start off, we're going to go over what a limit actually is, word-wise. So a limit is it's where your x value approaches some other arbitrary value. Let's say c, right? Your x value is going to be approaching c for some function, right? For some function that's going to give a value y. Right? So if you write this out, what this means is that your limit is going to be limit as x approaches c of f of x, right? And so what this is a dynamic process, right? Your like your value is never going to approach, like never actually reach your c value, but it's going to get so arbitrarily close to that value. And essentially what this is going to tell you is what that function is heading to, but not equal to, right? And so with that, there's a couple different rules that we need to know about limits before we can start actually approaching what's going on with the problems or even getting into them. So let's put limit rules. So the first one that we need to know is that for a limit, if you have a limit x approaching c, say some other arbitrary value a of x, right? So we're multiplying some value into f of x. This is going to be equal to us pulling the a term out and still getting the limit as x approaches c of x, right? And then it's going to be rule number one. So rule number two that we have here is that if you have the limit of x approaching another arbitrary term c of one function f of x, and you're adding it to another function g of x, all this is telling us is that this is going to be equal to the limit as x approaches c f of x plus the limit x approaches c of g of x. All right, pretty straightforward. And then for our third rule, if we have the limit as x approaches c of x times g of x, all this is going to tell us is that this is equal to the limit as x approaches c of x times g of x, right? Let me write this better. Of x times limit as x approaches c of g of x. Now, the last rule that we have here is that if you have the limit of x approaches c of x divided by g of x, this is going to give you, as you may guess here, the limit x approaches c f of x divided by the limit of x approaching c of g of x, right? But this also states that as long as the limit of x approaching c of g of x is not going to be equal to zero, because you can't have a zero in the denominator of the fraction, right? So, but going for that, there's going to be a couple different ways that they're going to be limit problems. So, the first one is going to be a direct input, I like to call. So, with a direct input, this, with a direct input, let's go with the first problem here. Our question is going to be as the limit approaches 4 of 2x, what is going to be the value? So, essentially, all you have to do with these direct input problems is don't even worry about its approaching. you're just gonna put in the value that x is approaching into your function and see what happens. So for this one, all we do, the limit, you got to make sure you write this part down to show that you're taking the limit of it. So the limit as x approaches 4 of 2x is going to be 2 input 4, and this is going to give us 8. So if we finish writing this all together, we get the limit as x approaches 4 of 2x is going to be equal to 8. And then we can just highlight value here. So let's just go over another one like that. So another one we have here is, let's say our function that we want to do is the limit as x approaches 4 of, let's say, x squared over 2x plus 1. And we want to know the value of this. So all we would do is do the limit as x approaches 4 of x squared over 2x plus 1. And then just like how we did before, we would plug in the value. Let's say you get 4 squared over 2 times 2 plus 1. And that's going to give you 16 over 5. And then you just highlight this. Wait, did I say 4? Hold on. Rewrite this. My bad. It's going to be 4. Hold on. And then that would give you 16 over 9. Then highlight this. So now a little bit more difficult problem would be, let's say the limit of, wait, the limit is x approaches 2 of g of x is what we want to find, right? And we know that the limit as x approaches 2 of 4 minus g of x over x is going to give us 5. So in order to evaluate for what g of x, the function as it approaches 2 is, we first need to figure out what even the function of g of x is. So essentially, this looks a little confusing, but how you would treat it is just like any other algebraic problem. All you have to do is just start moving terms around. So first things first, you're going to want to just drop the limit as x approaches 2. Don't even think about that. All you're going to want to do is start multiplying it across. So we're going to get 4 minus g of x is equal to 5x, right? And then we're going to shuffle our terms around. We're going to this here, and then we're going to do 5x, subtract 4 on each side, and then we're going to divide by that -1 and get that our function g of x is going to be -5x plus 4, right? And now we can evaluate the limit as x approaches 2 of our function g of x. So then when we do that, we just plug it in here, as x approaches 2 of g of x, where we know that g of x is equal to -x plus 4. And then we're going to plug in our term here. And then when we put that all together, we're going to get the limit as x approaches 2 of g of x is going to be -6. Just highlight our answer here. Now, that pretty much goes over everything you need to know about direct input. It's pretty straightforward. You don't really have to worry about too much. And then the next section that I like to call this, I call this manipulating the equation. It- Manipulating the equation. So pretty much what this means is that you're going to have to do something with your function in order to be able to plug in your value that your x is approaching, because you can't do it normally with how the function is already set up. So a first good example of this, since example one, is going to be we want to find the limit as x approaches 0 of x cubed over x, right? So when you try to plug in 0, normally what you're going to get is 0 cubed over 0, right? And 0 over 0, well, what the heck is 0 over 0? 0 over 0 is what we call an indeterminate form here. Indeterminate, indeterminate form. This pretty much means that there's more things that you can do to your function in order to be able to get a value. So in this case, what you can do is factor it out. So the limit as x approaches 0, x cubed over x, what you can do here is say you factor out an x, what you would get here is now you see there's an x over x, and then you factor it out, right? You factor out an x. So now we change the color here, change it to blue. Why not? You can now go, oh, let me cross out this x, let me cross out this x, and then end up with x squared. And then you can say, oh, can I plug in 0 into this? The answer is yes. And you get 0 squared, and 0 squared is just 0. So correspondingly, you can say the limit as x approaches 0, x squared is just 0. Now, another good problem with this would be, say we want to find the limit as x approaches 2 of x squared minus 4 over x minus 2, right? So similarly with how what was going on in example one, if we plug in the value that we want our x to approach, we're going to get, let's just do this for example here. We're going to get 2 squared, which is just 4 minus 4, and then we're going to get 2 minus 2, and we're going to end up with 0 over 0, right? We got our indeterminate form again. So with this problem, what we have to recognize here is that we're able to factor our x squared minus 4. And what we can get here is this x approaches 2 of x minus 2, x plus 2, x minus 2, right? Because then if you FOIL this out, your x minus 2, x plus 2, you get x squared plus 4, difference of squares. And then, just like how we did in our last problem where we canceled terms out, we can cancel out our x minus 2 terms and then end up with x plus 2. And then we can say, oh, the limit as x approaches 2 of x plus 2, that's just going to give us 4. Then we can highlight that and say, boom, that's our answer. Then the last problem that I would say is good to go over when it comes to limits of 3. Let's go over the limit as x approaches 0 of the function square root of 1 minus x minus 1 over x. So just like before, I'll show you what happens when you try to plug in a 0. You get 1 minus 0. Well, 1 minus 0 inside the square root, which is this 1. So 1 minus 1, that's 0. And then you plug in a 0 for x. And so you end up with 0 over 0, right? So the key thing that you have to remember here is we write this down here so we can start working with the problem. Is we need to remember our conjugate theorem. Like not our conjugate theorem, but our conjugates. What you have to do is multiply this by the conjugate so that we can start canceling out that square root. So what you do here is you multiply your equation by the opposite sign. So for this one here, our sign is a negative. So what we're going to do here is multiply this one by a positive and then put this at the bottom here. Square root of 1 minus x plus 1. And now after we do that, all we're going to want to do is just multiply it across. And with that, we're going to end up with a square root multiplied by a square root. Remember, they just cancel each other out. So 1 minus x, 1 times 1, that is just going to leave us with -1. And then I'm not going to multiply the x inside this term. I'm actually just going to leave it here because I think we might be able to cancel something out later. And then when we do that, we can come here and see, oh, wait, it looks like these ones on the top cancel. So we're left with -x over x parentheses 1 minus x plus 1. And then it looks like we can do something else with this, which is taking out another x, and then we'll be left with -1 over the square root of 1 minus x plus 1. And then we have to, hold on, let me move this over so it's a little better. So it's clear. This plus 1 is not included in the square root. And so then we have to remember what we're actually trying to do. We're trying to find the limit as x approaches 0 of this function, right? So now that we have it in this term, we see, can we plug in a 0? Well, the answer is yes now, because 1 minus 0 is just 1, and square root of 1 is 1. So 1 plus 1 is 2. And so we get that our answer here is going to be -1/2. Let's highlight that. And then with that, that pretty much covers everything that we need to know about limits. To pretty much wrap up everything that we need to know, we need to know that a limit is where a function is approaching some value of x, some arbitrary value of x, and we want to know what's happening as it's getting really, really, really close, but not at that point. And then we also need to remember our basic limit rules, which being if we're multiplying our function that we want to take a limit of, we can just plug out the value that we're multiplying from, take the limit of the function, and then remultiply it by that value. And then that if we have two functions added together and we want to take the limit of both of them, we take the limit individually and then add them together. And then another thing is that if we want to take the limit of two functions multiplied together, similarly like with addition, we just take the limit of each function separately and then multiply them together. And then if we want the limit of two functions being divided by each other, similarly, we take the limit of each function separately and then divide them. As long as your limit as x approaches your bottom term, in this case with the example that I wrote down, g of x, as long as it's not equal to 0. And then remember our direct substitution, we're just going to be plugging in our value that x is approaching into our function, and that's going to give us the value that the function is approaching at that value of x, or getting close to that value of x. And then going over manipulating equations, all we have to remember is a couple techniques that we can use to manipulate our equation. One being factoring out, just plugging terms out and see if we can cancel something out. Factoring, seeing if we, like what we had with example 2, if we had any perfect squares or something like that. And then like example 3, if we had any conjugates, and remembering that a conjugate is just the opposite sign of what's outside the square root. Like with the one we had here, we start off with a negative square root. Well, not a negative square root, but something being a square root being subtracted by a negative, or it could be the other way around, a number and then subtraction of a square root. But either way, it's going to be the opposite sign of that. Multiply that, and then cross out any terms that you can, and then try to plug in your value that x is approaching. And with that, that's going to